Hello, my name is Will Simonson, and today I will be going over the Physics 2 Lab 2 Charge Tape Revisited. And so for this lab, the introduction, the goal was to determine the charge on tape B, as you can see the picture in the top right, so that it can be repelled enough to float above tape A. And so the fundamental principles of this lab are Coulomb's law, and you can see in the bottom right corner the equation for Coulomb's law. You have the electric fields turning into forces from the net electric field and the positive and the negative charges. And you can see the other fundamental principle is the law of superposition, where there are multiple charges away from an observation point, and at that observation point you sum the electric fields to get a net electric field, which is what is used in this lab. And so for the results, the point particle charge from lab 1 would be negative 5.6 times 10 to the negative 9th, and using a line charge it's negative 6.79 times 10 to the negative 9th. These values are also used in the what if at the end. And in the top right you can see values obtained from the first lab, and for lab 1 you could assume that you can ignore air resistance. The tape is treated as a point charge, and the tape also had an evenly distributed same amount of charge. You can see bottom right I also included the model from lab 1, and you can see the point charge has an electric field, and that field acting on the tape, what you can see is the ball with the two arrows, has the gravitational field, which is going down, and the opposing net electric field. So for lab 2, each piece of tape has several equal segments, with each segment modeled as a point charge and applying the law of superposition. For the assumptions, you can see that air resistance would be negligible, just like in lab 1. Each piece of tape has the same charge, and there's an equally distributed charge along the tape. And so the force calculated due to the electric field would be force is equal to the charge times the electric field. And in the model, which you will see below, the white stands for the electric field force, and the yellow is the gravitational force. So for experimental values, another important principle that was taken into account was for the tape to be suspended, the force of the electric field of the tape had to be equal and opposite to the force of the gravity. And you can see that if you move it to the other side, the force of the electric field plus the force of gravity would be equal to 0. The acceleration would be equal to 0. And so for data and calculations, this was also some numbers that were shown in 2 slides ago. And basically these were used to calculate the R vector and the amount of point charges. And so the code you can see here, there was the mass of the tape, and the net charge, and the length, and the distance, and these were used in the next part to define the electric field, and then using Coulomb's law to establish that electric field vector, and to model this code, and also including this code right here, which helps show that there are going to be multiple point charges, and there is going to be a law of superposition where the force of gravity is shown in yellow, and the net electric field is shown in white, and they will be opposite but equal. For sources of error, the tape may have lost or gained charge due to something else, such as maybe you touched the tape and it transferred electrons, or the charge on each piece may have not been equal piece of tape. And so what if you had modeled each of your tapes as a single point charge compared to a line charge, which we use in this lab, and the magnitude of the line charge model was greater. There was more more electric field and superposition acting upon that point, and the force of gravity had to equal it. And so why do these estimates differ? What value will more likely be closer to real value? the line charge model is more likely to be the real value because it is closer to an accurate representation of the interactions going on in the real world, where the tape is not in fact a point charge, but there are electric fields from different electrons in the tape running along it. So this leads to a higher magnitude because there are more forces acting on the tape. Thank you.